Firstly, we measured out a 50-metre stretch, marking each 10-metre interval with a cone.
Do it in a straight line.
Next, we had Neth run the 50-metre stretch, recording each of his times at every cone. Neth gets off to a great start, travelling the first 10 metres in 3.14 seconds. We can calculate Neth's average acceleration during this period using the formula acceleration equals velocity divided by time. We can calculate Neth's velocity using the formula velocity equals distance over time. We can combine these two formulas to receive the new formula acceleration equals distance over time squared. We can now use this to find Neth's average acceleration by subbing in distance equals 10 metres and time equals 3.14 seconds. This means that Neth's average acceleration for the first 10 metres is about 1 metre per second squared. As Neth continues to run, we can draw up a table of distance, time and acceleration. Neth ran 10 metres in 3.14 seconds, and so his final acceleration is 1 metre per second squared. Neth then continued to run to the third cone. However, this time we had to take away initial velocity from his final velocity to get delta v, required for the acceleration equation. We also found delta t by taking away Neth's time at the second cone from Neth's time at the third cone. We can now fill out the whole table as Neth runs the full 50 metres. Now we have this table of results, we can analyse Neth's running, where and why his acceleration peaked, and his total average acceleration. It is clear from this graph that Neth's acceleration was greatest when he was between 10 and 20 metres, but towards the end he clearly got tired and began to slow down where acceleration is negative. This graph here shows velocity versus time, and through this we can better understand the acceleration of Neth. The gradient of this graph is the acceleration of Neth for that period. This becomes very obvious when we see them one above the other. There were many errors involved, including timing errors and measurement errors, and we could have improved this experiment greatly by using digital laser timing and measuring distances more precisely. Also, a great way to improve the accuracy of this experiment would be to do it in a frictionless vacuum, but this was unable to be found.